Well, hello, functions. Okay, we started with this warm-up based on yesterday's learning. And one of the things that came out while we were going through this was that we needed to figure out how to find these. So go ahead and hit pause and put these in your notes, and then try to answer them on your own without a calculator. The more you practice, the better you'll do. You don't want to use a chart because you're not going to have that, so try to do this without your notes. And try to come up with a strategy that you can use without a calculator, because these are the kinds of questions we'll be asking on a test. So go ahead and hit pause. So hopefully you got that this was 4. And the reason why that's 4 is because we talked about this yesterday, that if anything taken to this power, if is this the nth root of a is equal to b, then that means that b to the nth power is equal to a. So we looked at this example. The square root of 36 is 6 because 6 squared is 36. So this is 4 because 4 to the third power equals 64. So then we go here, we figure out, well, 9 times 9 is 81. 81 times 9 is going to be, there we go. In class, I handed out these little papers. So if you didn't get one to help you come up with some division rules, that'll help you figure out what base to start at. So I knew I could start at 9 since that the sum of the digits is divisible by 9. So if you add 7 plus 2 plus 9, you can divide that by 9. So if you didn't get this in class, come see me in class and I will give this to you. If you're in Miss Wadley's class, you could still ask me for it. I have some extras. I don't know if she passed those out. So again, because 9 to the third power is equal to 729. Again, we could use that same strategy. I use my finger, so 5 times 5, so 5 squared is 25. 25 times 5 is 125. 125 times 5 is 625. 5 to the fourth power is 625. So that is why that works. Here, their answer should be 3. And then this one, remember, we can rewrite this as the 6th root of 729 over the 6th root of 4096. And then we could just find each one individually. So the 6th root of 729 is 3, and that is because 3 to the 6th power is 729. And the 6th power of 4096 is 4. This one was a little bit tricky. The way that I do it is I think, well, what would be the cubed root of 343? Well, that would be 3. I'm sorry, that would be 7. So 7. And then I just need to figure out what do I need to do to my decimal. So a lot of students said it was 007, but remember, I want to find that cubed. So that's going to be equal to 0.7 times 0.7. And remember, we just multiply it normal, so we get 49. And then we move the decimal 1, 2 places, so 1, 2, we get 0.49. And we're going to multiply by 0.7 again, and we get 343. And we need to move the decimal place 1, 2, 3, 1, 2, 3. Okay, that's the answer we get, so 0.7 is correct. Alright, so we're going to talk about principal roots. This is a fancy way of saying real solutions. So real solutions meaning not imaginary. So this is kind of a wordy thing that you want to put in your notes. So if our n, this right here, is even, if it's even, and our radicand, or the number underneath the radical, is positive, then we are going to have an answer. So a good example of that would be like the square root of 16. Well, that is equal to 4. We have an answer. Remember, if the number is not written here, it's a 2. That is a even number. This is a positive number. This one is saying if we have a -1 or a negative out in front of it, then that's like -1 times the square root or the nth root of a. So that would be like we took negative square root of 16, well, that would be -1 times the square root of 16, which would be equal to -1 times 4, which is equal to -4. So the answer would be -4. So if the negative is out front, then it's like a -1 being multiplied by the radical. Even if this is an odd number, that's still true. So if our index is even and our radicand is negative, so that should say negative a, then we do not have a real solution, because let's do an easy one. So the square root of negative 4. This would be 2, so that's even. That would be the same as saying the square root of 4 times the square root of negative 1. Well, those of you that remember Algebra 2, the square root of negative 1 is I. It's imaginary, so we would get 2i. So if we are asking you to find the square root of negative 4, you are going to say no real solution. So, but here's the thing. If our index is odd, then we will have exactly one real solution if our a is negative. So what we would do is, if I have the cubed root of negative 27, I would get negative 3. And that's because, watch, negative 3 times negative 3 is equal to positive 9. Positive 9 times negative 3 is equal to negative 27. So that is why we get negative 3 is our solution. So if it is odd, then we do have an answer, and we need to find it. It might, it could be negative, it could not be. It depends. So here's some examples. Go ahead and get these in your notes. All right, hit pause. Good. I'm glad you got these in your notes. So if we were to find the square root of 36, and that would just be 6, because we're finding the principal root. The square root of the negative square root of 36 would be negative 1 times the square root of 36, which would be negative 1 times 6, which is negative 6. How about the fourth root of 16? Well, that would just be simply 2, because 2 times 2 is 4, times 2 is 8, times 2 is 16. And then this would be negative 1 times 2, or negative 2. But what about this one? The negative is underneath, my index is even. This does not have a real solution. This says no real solution. The fifth root of 243 is 3. And the fifth root of negative 243, so we're going to have to figure this out. So negative 3 squared is positive 9 times negative 3 is negative 27 times negative 3 is positive 81 times negative 3, which is a negative 240. I wrote it wrong. Sort of got a little crazy with my number writing. Fix that. Which is a negative 243. So this is negative 3. And we found that by going back and forth. Negative 3 to the 5th power. So make sure you get that in. So to summarize what we learned today, if our index is even, then we need to be cautious of any negatives under the root. Okay? And if our index is odd, we need to be cautious that we find a solution. All right, if you have any questions, please ask Ms. Wadley or myself. Otherwise, you have a great day. Thank you guys so much, and I will see you all tomorrow. Now you should be able to do questions 1 through 12, if not more. I think maybe 21, now that you've seen all of these. There might be some that you need to skip, but we have a few weeks to get them all done.